Okay, welcome back. This is a continuation of section 11.1. This is for statistics class again. When we left, we had set up the hypothesis statements and defined the parameters of interest for our first two-sample t-test. Now, what we're going to do now is we're going to write down the sample characteristics, and I have them right here from the study. First of all, for the Facebook users, N, I guess I should write a little N. The sample size was 141. The sample mean was 3.06. And the sample standard deviation is 0.95. Okay. For the group of students who did not use Facebook, the sample size was 68. The sample mean was 3.82. Okay, that's the mean GPA. And the sample standard deviation, and my goodness, I just realized I forgot to use subscripts. Okay, I need to, since we're dealing with two different sets of data. So this is N sub F, X bar sub F, and S sub F. Those are the Facebook groups. This is N sub N, X bar sub N, and S sub N. And S sub N is 0.41. Okay, so now we assumed that each one of those samples was selected at random. And here's the key. They were selected independently of one another. Okay, to use this test, that is one of the assumptions. Okay, now I've got the sample statistics written down. I'm going to name the procedure, which is, this is a two-sample t-test, and that is what it's called on your calculator. I guess the silver lining for you guys always carrying the school calculators around with you is now, in the event of a pandemic, you already have them at home. Okay, so yeah, good job. Okay, so I've named this. Now we're going to check the conditions. Okay, condition number one, or letter A, is these are two independently chosen random samples. Okay. Now, as far as normality of the sampling distribution, if you think about it, we really have two sampling distributions to deal with here. Okay, so we have to check for normality of each one of the sampling distributions. The sampling distribution of X bar for this population and the sampling distribution of X bar for this population. Now, the way we check them is the same. It's just we've got to do it for both of them. Okay. Now, in this case, both sample sizes are greater than 30. All right. So that in itself allows us to assume normality of the sampling distributions, okay, plural. If that were not the case, we would have to make two box plots. Okay, if say this sample size was 20 and this sample size was 15, we would need two box plots to justify normality of each one of those sampling distributions. Okay, just like, we had to make one box plot when we were dealing with a one sample t-test. Okay, so I'm going to write, since N sub F is greater than 30 and N sub N is greater than 30, we can assume normality of the sampling distributions. Now it's two distributions. I have to make sure you put the S on the end of the word distribution. Okay. So independently chosen random samples, and we can assume normality of the sampling distributions. Okay. Now let's look at what our test statistic is going to be here. So I'm going to erase this bottom part here. And I'm going to put the formula for T up here. All right, T is this. Okay, it's the observed difference in sample means, x bar sub f minus x bar sub n. Okay, I'm going to put that in a quantity, minus the hypothesized difference in sample means. So that is mu sub f minus mu sub n. Okay. So it's the same structure in the numerator. It's the observed minus the expected. It's just the observed difference in sample means minus the hypothesized difference in population means. And then the denominator is still the standard deviation of the sampling distributions put together. Okay, because remember we have two sampling distributions here. So this is how we do it. This is going to be S sub f squared over n sub f, and then plus S sub n squared over n sub n. Okay, and that's the formula. You know, if you're going to do calculate a value of t by hand, that's how you do it. Now, let's talk about the degrees of freedom here. And by the way, you don't have to memorize that formula or anything. That would be given to you. The degrees of freedom. Okay, now, I'm just going to be honest, okay? The formula for calculating the degrees of freedom here actually is extremely complicated. Okay, no jokes. It's not just n minus 1. Okay, you're welcome to look that up in your textbook. Okay, you won't ever actually have to calculate that by hand though. If I run this test on the calculator, it will give me the degrees of freedom, and then I can just write it down. Or I can use a conservative estimate. Okay, now listen. A conservative estimate for the degrees of freedom for this test and any two-sample t-test is just you take the smaller of the two sample sizes and subtract 1. So for instance, this, you know, the smaller of the two sample sizes was 68. So I could just make my degrees of freedom 67. However, if I go ahead and let the calculator calculate the number of degrees of freedom, I'll get a more powerful test because a higher number of degrees of freedom is going to take that t distribution closer to the z distribution, okay, which is going to make the rejection region small. Okay, now I'll write down the degrees of freedom here after I do it on the calculator. And actually, I wrote it down already. I just can't remember what it was. Okay, I do need to choose an alpha level. We'll just go 0.05, 0.01, 0.05. Those are both excellent choices for your alpha level. Now we're going to, I'm not going to calculate t by hand here. I did it on the calculator a bit ago. And when I ran this, sorry, I got to get my sheet here. I got t is negative 8.07. All right, and then for my degrees of freedom, I got 205.098. Now, if you calculate it by hand, what you do is you don't round your degrees of freedom to the nearest whole number, you truncate it, right? So even if that were like, if you calculated like 205.9, you're still going to go down to 205, okay? You don't round up to 206. You always truncate your degrees of freedom. All right, so there, okay, so, and then, you know, from the calculator as well, the p-value here is essentially 0. It's 0 to however many decimal places the calculator calculates it. So we all know what comes next, right? After you've got your p-value, we're going to make our conclusion statement. So we'll make a little room here. Okay, and so I'll write, since p is less than alpha, we reject h naught at the 0.05 level. Okay, so that's number one. And then, so we there is sufficient evidence, right? There is, I'm going to abbreviate a little bit here, evidence to conclude that the mean GPA for Facebook users, remember, is actually less than the mean GPA for non-Facebook users. Okay, I'm going to say that one more time so I don't have to write it. Okay, there is sufficient evidence to conclude that the mean GPA, the true mean GPA for Facebook users, is less than the true mean GPA for non-Facebook users. Okay, that's the first hypothesis test in a 11-1. I'm going to stop here because I know this video has gotten kind of long. Okay, stay safe. See you in a bit.